Hi students, welcome in chemistry classes, and today's topic is spectrophotometric titration. In our last lecture we have studied about the complexometric titration, and I have told you there that for detection of the endpoints we use three things. One is the use of the indicator, another one was the use of a spectrophotometer, and third one is the use of ion selective electrode. So the second method, that was the use of the spectrophotometer, makes the basis of the spectrophotometric titration. It means here the titration is done with the help of the spectrophotometer. It means by the absorption of the light in the visible region. Okay. So this method is used in the case of the colored solutions. We have seen in the complexometric titration, we do the complexometric titration mostly with the colorless solutions with the help of indicator. In the case of the colorless solution, it means when there is no color in the solution, then we can use indicators easily and we can see the change in the color of indicator very easily. But what happens when we have given a colored solution? In the case of the colored solution, the solution is already colored, okay, and when we are adding the indicator, then we cannot see the change in the color of the indicator at the end point because the solution is colored. Okay, so in such cases we use the spectrophotometer. Okay, suppose we have given a copper solution. This is the solution, that is our analyte solution. Okay, and we are doing its EDTA titration, and for this titration we have to add ammonia. Why? Because it is acting as a buffer solution for fixing the pH of the solution. Okay, so when we are adding the ammonia to the copper solution, then it will form the complex. We know such type of complex is formed here, CuNH3 whole 4 plus 2. Okay, you all know about this complex, and we know that this complex is intensively colored. Okay, and if we are adding the indicator, then we cannot see the change in the color of the indicator. Why? Because the solution is intensely colored. Okay, so in such cases we have to use the spectrophotometer. Okay, so this is used in the case of the colored solutions. And what is the main requirement for this titration? The basic requirement is this, that firstly see here what is happening here. We have given a analyte solution. Okay, this is the analyte solution, we are denoting it by A, and we are adding from the burette the titrant like EDTA. Okay, and that is denoted by T. As a result of the reaction, there is the formation of the product, right? In the case of the EDTA titration, it will be a complex. Okay, so this product we can denote by P. Okay, so by the reaction of A and T, P is formed, right? So the basic requirement for this titration is that either this A or this T or this P should be colored. It means for any of them, the absorbance that is denoted by A or molar extinction coefficient. If you have studied the video of the UV spectroscopy, I think you all know about the absorbance and the molar extinction coefficient. This is denoted by epsilon. Okay, so this thing for either A or T or P should not be equal to 0. Okay, this is the main requirement for such type of titrations. Okay. Okay, now we have to understand the basic principle of the spectrophotometric titration. This all titration is based on the absorption of the light. We know why a solution is colored. The solution is colored due to the absorption of the light in the visible region. It means it is absorbing somewhat light at a particular wavelength. Okay, and we can calculate the absorbance by the spectrophotometer. Okay, and we know that the absorbance is given by the Beer-Lambert's law. What is the Beer-Lambert's law? I think you all know. What is Beer-Lambert's law? that is absorbance is equal to epsilon dot C dot L. Okay, here this is the absorbance, this is the molar extension coefficient, C is the concentration and L is the length in the centimeter, right? So by this formula we can calculate the absorbance. Okay, so here we know that for the either for the analyte solution or for the product or for the titrant, this absorbance or this epsilon, the molar extension coefficient, should not be equal to 0. Okay, so what is happening? Suppose we are taking the same analyte Cu plus 2. Okay, we are taking this, and in the solution here is the NH3 as the buffer, it is present. So as a reaction of them, here Cu NH3 whole 4 plus 2 complex is formed, right? Now we are adding the, this is present in the solution. Okay, here in the solution this complex is present. Okay, now from the, this is suppose the burette. Okay, and from the burette we are adding the EDTA solution. Okay, we are adding this solution as the titrant. This is our titrant, this is the analyte solution. Okay, so what is happening? What reaction will happen here? This is our complex that is present in the solution and this is aqueous. Okay, it will react with the EDTA and we represent EDTA in this manner. This is also aqueous. Okay, so as a result of their reaction, here Cuy minus 2 aqueous is formed and NH3 is formed. Okay, now from the reaction you can see here, this is colored, our analyte is colored. Okay, and titrant is colorless. This is our titrant, this is colorless, and as a result this is the product that is formed and it is also colorless. Okay, so now we have to plot a graph. We have to plot a graph here. See here, what type of graph we are seeing here. In the case of the spectrophotometric titration, we are plotting a graph between the absorbance and the volume of the titrant. Here on the x-axis we are plotting the volume of the titrant and on the y-axis we are plotting the absorbance. Okay, so see here what is happening here. In the first case, in the initial stage, we have the analyte in the solution, right? We have given the analyte and analyte is colored, so it will have the absorbance maximum. It means suppose here is the absorbance in the initial state. When we are adding the titrant is colorless, right? And we are adding this, so as a result the product is formed, right? Now in the solution there is the analyte as well as the product. The amount of the analyte is decreasing and the amount of the product is increasing, but the product is colorless, so absorbance is decreasing. It means it will decrease in this manner, right? This is the absorbance that is decreasing here, right? Now at the end point this is minimum. Okay, and after the end point we are adding the titrant, so the amount of the titrant is increasing now, right? And titrant is also colorless, so now there will be no change in the absorbance. It means it will go in this manner. Okay, so we are getting a plot in this manner. Okay, you have to understand this all thing very clearly, because in the question papers you will see the graph of such type, and if you know this whole mechanism then you can do such type of questions quite easily. Okay, now we have to see various type of curves, because in this whole spectrophotometric titration the curve is the only important thing. If you know the curves better, you can do these questions quite easily. Okay, so first type of the curve is for when the analyte has the absorbance not equal to 0, it means analyte is colored, and titrant and product have the A is equal to 0, it means they are colorless. This is the same situation as I have told you in this lecture of the CuNH3 whole 4 plus. Okay, so here we are getting in this way. Here is the absorbance and this will be the volume of titrant. Okay, so what will happen here? In the initial state, the absorbance will be maximum and then the product is formed. So the absorbance is decreasing in this manner. Okay, and then at the end point this will be minimum and then it becomes fixed. So we are getting this way line because the product is also colorless. Okay, so this is the same situation. By intersecting at this point we can get here the end point. Okay, the next situation is when analyte and the product P, for both the absorbance is equal to 0, it means both are colorless. Okay, this is colorless, A is equal to 0, and titrant is colored, it means for it A is not equal to 0. Now what will be the situation here? See here. This is the absorbance and this is the volume of titrant. Okay, so now see here, analyte and product both are A is equal to 0. It means in the initial state, suppose the absorbance is here, this is minimum because it is not absorbing. Okay, this may be here. Okay, and the product is also colorless. Okay, so when we are adding the titrant, the product is formed. So this is the formation of product. Product is also colorless. Okay, so the absorbance will remain minimum. Okay, and at the end point, this is suppose the end point. Now we are adding the titrant. We are adding more titrant. So there will be excess of titrant, but titrant is colored. Okay, so absorbance will increase. So now it is increasing in this manner. It is increasing, right? It is increasing in this manner. Okay, so we are getting this type of graph, and by intersecting this we can get the end point. This is the end point. Okay, now see the third type of the situation. When only product is absorbing. Product absorbs means for P, the A is equal to not 0. It means A is not equal to 0. It will have somewhat absorbance. Okay, and for A and T, it means for analyte and titrant, the absorbance is equal to 0. Okay, so see here which type of graph we are getting. We are plotting a graph between the absorbance and the volume of the titrant. I am not writing it again and again. So see here, this is the analyte, that for that absorbance is equal to 0. It means it will be somewhat here. Okay, this is the minimum condition as I am showing you. And then the product is formed. We are adding titrant and the product is forming. Product is colored. So A is not equal to 0. So absorbance will increase and increase and increase. Now we are getting the end point. Okay, so after end point we are adding titrant. So there will be the increase in the volume of titrant, there will be the excess of titrant. Okay, now for titrant the absorbance is equal to 0. It means now the absorbance will not increase, it will remain in this manner. Okay, by intersecting this we can get here the end point. So this will be the end point and we are getting such type of graph, right? Now see the fourth type of the graph. When analyte and the titrant both are absorbing, it means for them A is not equal to 0, and for the product P, the absorbance is equal to 0. Okay, so see here which type of plot we are getting, you can make yourself it, because this is quite easy. Okay, see here, for analyte absorbance is not equal to 0, it means it is colored, so it will have somewhat absorbance like here. Okay, and when we are adding the titrant, product is formed. We cannot count for the titrant because here titrant is reacting with the analyte and product is formed. Okay, so firstly we have to see for the product, and product has the A is equal to 0, so the absorbance will decrease and decrease and decrease. Okay, and then at the end point, what will happen? At the end point, now the product is not formed. Okay, now we are adding the titrant, then the amount of titrant will increase, and for titrant absorbance is not equal to 0, so it will increase and increase. As we are adding the titrant, it will increase. Okay, and by intersecting these points we can get here the end point. Okay, so such type of graph we are getting here. Okay. Okay, now see here this question from CSIR net June 2013. Same type of questions are asked in the gas as well as in the IIT JAM question papers. Okay, so I have taken here the one question for the sample. Here is in complexometric titration, substrate and titrant are reacting and forming the product. Okay, the end point is estimated by spectrophotometer, and if for the substrate and product the epsilon is equal to 0, then what is the shape of the titration curve? It means we have given that for the analyte and for the product, absorbance is equal to 0 or molar extension coefficient is equal to 0. It means they are not absorbing, they are colorless. It means in the initial state, the analyte is not absorbing, so absorbance will be minimum. Now we are adding the titrant and product is formed, but product is also not absorbing. The product is also not absorbing. Okay, so what will happen? This absorbance will remain as it is. Okay, now here we have not given about the titrant. It means the titrant is colored and it is absorbing. These two are not absorbing, but titrant is absorbing. So after the end point, by adding the titrant, the absorbance will increase. So there is a increase in the absorbance. So such type of curve we will get here. Okay, all other will be the wrong answer, but only this option number B will be the right answer. Okay, so if you know a little bit about this absorbance and which type of curve we are getting, then you can do such type of questions quite easily. Okay, so do such type of questions yourself. If you get any complication, you can comment us. Meets you in the another video. Thank you.